Hey y'all, in this video we are going to go over powers and the order of operations. For your notes, I am not going to be showing you completing them, but I have tried to underline and indicate all the things that you need to write down in your notes. Our I can statements here in our second lesson is I can calculate powers and I can evaluate a numerical expression using the order of operations. Our essential questions for you to write down: what is a power and how do we evaluate expressions? So a power is an expression itself written with an exponent and a base, or it's the value of that expression. Here, 3 squared is an example of a power. We can see that 3 is the base. This is the number that is being used as a factor. And 2, the exponent, that tells us how many times the base is used as a factor. So in this case, we would be doing 3 times 3 because we are using the base of 3 and doing it twice. So let's fill in your table together. 3 to the first power would just be 3. We could see it written as 3 with a 1 in the exponent, and that value is just 3. 3 to the second power, 3 to the second power, or 3 squared, because a square would be a number times itself, would be 3 times 3. We see this written as 3 squared, and the value is 9. So 9 is a power of 3 squared. 3 to the third power, or we could say 3 cubed, because the volume of a cubed is a number times itself 3 times. So in this case, 3 cubed would be 3 times 3 times 3, which looks like 3 with an exponent of 3. And when we multiply that out, we get 27. 3 to the fourth power, well, that would be 4 3's multiplied together. It would look like 3 as the base with 4 as the exponent. And when you multiply those out, you get 81. 3 to the fifth power would then be 5 3's multiplied together. It would look like a base of 3 with an exponent of 5. And the value when multiplied out is 243. So that is how powers work. We have a base and an exponent, and we are multiplying that base to itself the number of times indicated in the exponent. Let's look at a couple examples. -2 squared. This means that we are going to write out -2 times -2. Oh, and I've made a mistake here. That should say +4. I'm sorry about that. So -2 times -2 is +4. Whereas the next power here, we have -5 squared. The squared is only on the 5. So when we do that out, we have negative and then 5 times 5. So it's -25, because 5 times 5 together is 25, and we put a negative in front of it. This is like saying the opposite of 5 squared. 5 squared itself is 25, and the opposite of 25 is -25. One last example to look at is a fraction taken to a power. It's still going to be that number times itself, 4 times in this case because that exponent is 4. When we take and we multiply a fraction, we multiply all of the top together and all of the bottom together. So when we write this as one fraction, we're going to have 2 times 2 times 2 times 2 on top, and 3 times 3 times 3 times 3 on bottom. 2 then to the fourth power. 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 to the fourth power, 3 times 3 is 9, times 3 is 27, times another 3 is 81. So this is 16 over 81. And we can see all of their factors listed out here. 16 can only be divided by 2's or even numbers, and 81 can only be divided by 3's. So these don't have any factors in common. We cannot simplify this any further. 16 over 81 would be our answer here. Now let's take a look at our order of operations. Our order of operations have 4 parts: G for grouping symbols. And these grouping symbols include parentheses, brackets, and braces. I've given you a visual example of each, and I've underlined the words so you know what to write down. If an expression contains more than one set of grouping symbols, we're going to evaluate from the innermost set first. We're going to go inside out. Fraction bars, square roots, and absolute value symbols can also be used as grouping symbols. We're going to do the insides of those first before anything else. Do remember that the fraction bar does indicate division. So simplify the numerator, then simplify the denominator as separate groups before you do that dividing. Then we have exponents, aka powers. We're going to simplify these in order from left to right. This does include our radicals at this time, or our square roots. They are technically a power. Next is multiplication and division. So anything that's multiplication and division, we're going to do it this time. And we're just going to do this from left to right. So the way that you would read a book, left to right. Same with subtraction and addition. They're done at the same time, and we just do it from left to right. This brings our acronym GEMS, or GEMS. Let's take a look at a couple examples. I'll do the first two, and then you try the second two, and then check to see if you're right. So with the first two, -4 squared plus 24 divided by 3 times 2. So we don't have any parentheses or grouping symbols we need to worry about, but we do have an exponent. When we evaluate that exponent, remember we're just squaring the 4, and 4 times 4 is 16. So we have -16, then plus 24 divided by 3 times 2. Now we do multiplication and division, but we're going to do it from left to right. So as we read our expression, the first thing we get to is 24 divided by 3, which is 8, and then we multiply our 2, which is 16. So now we have -16 plus +16, which gives us a final answer of 0. Our next one, we have a couple of grouping symbols inside grouping symbols. We have parentheses inside brackets. Remember, we're going to do the inside first, so we're going to do that 5 minus 2 first. So 5 minus 2 is 3, and then with that, we're going to do our 3 squared, which is 9, and 25 minus 9 is 16. Now, as I was preparing these slides, I forgot to do this multiply 4. So multiply 4, we can just do that right here. We're going to take this, and we're actually going to multiply it by 4. And 16 times 4 is 64. So the answer for that second one is 64. You try the other two, and then pause the video, try them, and then play the video to see if you got them right. So for the fraction, -22 minus 2 squared over 5 minus 3, we'll do that squared first, subtract on top, subtract on bottom, and finally divide to get -13. For the last one, 5 squared times 30 minus x, it says to plug in 24 for x. We'll subtract to get 6. 5 squared is 25, and 25 times 6 is 150. The last thing to fill in is the underlined portions for your summary. To remember that a power is an exponent and represents repeated multiplication. And the order of operations tells you what order to evaluate an expression. So we do grouping symbols, then exponents, then multiplication and division, and finally subtraction and addition. Your next steps are to complete the worksheet in your packet, which has 9 practice problems for you to do, and then take your mastery check. Good luck, and I'll see you in the next lesson.